Hello friends, in this video lecture I will be talking about electronegativity, and this is one of the fundamental concepts for organic chemistry. This will lead you to understand inductive effect, mesomeric effect. Moreover, electronegativity has applications to predict acid strength and basic strength, and also it gives you the idea of the polarity of the bond, that how much polarity, what is the degree of polarity between two atoms or molecules. Alright, the definition of electronegativity is a measure of an atom's attraction for electrons in a bond. This is how we define an electronegativity. In simple words, consider two people pulling a rope, and if someone has more electronegativity, the rope will go towards that side, and if someone has less potential of electronegativity, the rope will be less on that side. So let's translate this effect into the periodic table. Consider this side of main is left side is this lithium, and this guy is fluorine. So if you can see in the periodic table, the highest electronegative element in the periodic table is fluorine, having electronegativity of 4.0. so the electronegativity for this guy will be much higher than this one. Let's have a look at the trend of electronegativity across periodic table. The electronegativity decreases across from left to right. So if you see, the electronegativity is minimum in lithium group and maximum in fluorine. Similarly, electronegativity decreases from top to bottom and also increases from bottom to top. If you see here, electronegativity is 2.2 at the bottom, and it goes up until fluorine and it becomes 4.0. So electronegativity increases in two ways, from left to right and bottom to top, and decreases from top to bottom. By the way, this electronegativity concept was given by Linnaeus called Pauling, and he introduced the bond polarity and electronegativity concept. This fellow, he was born in 1901 and died at 1994. These are the two key points that I mentioned, that electronegativity increases across the row of periodic table and decreases down the column. What is the application of electronegativity? It gives you an idea to predict the nature of bond present in any molecule. Let's have a look at this chart. If the electronegativity difference between the two atoms is 0, then the bond will be called pure covalent bond, or the bond exists in that molecule is pure covalent bond. If you consider the example oxygen O2 atom, or if you look at this, if you minus 2.5 minus 2.5, the net result will be 0, and the bond exists between these atoms is pure covalent. If the electronegativity difference is intermediate, the bond will be polar. If the electronegativity difference is large, the bond will be ionic. Let's have a look at this table, which classifies the electronegativity difference and gives the information about pure covalent bond or polar covalent bond or ionic. If the difference is less than 0.4, that is called pure covalent bond. If the difference is 0.4 to 1.8, that's called polar covalent. If the difference is greater than 1.8, the bond is called ionic. Have a look at this bond that is between carbon and carbon. Now translate the effect of electronegativity in the organic chemistry. So the electronegativity of this carbon is 2.5, and this is also 2.5, and the net result will be 0, hence the bond will be non-polar. And this is how you can get information via electronegativity to pick the compound will be polar or bond will be polar or non-polar. Have a look at the bond between carbon and hydrogen. These are the two most common bonds which you find in organic chemistry, like hydrocarbons, alkanes, or whatever you can name it. See, the difference between carbon and hydrogen is not much, hence the bond will be non-polar, but the carbon has more electronegativity, hence it can pull electron from hydrogen. But the most significant example in organic chemistry which will allow us to identify the electrophilic and nucleophilic character of any atom in any compound can be determined via electronegativity. This group, carbon single bond oxygen or carbon double bond oxygen, exist in a variety of functional groups such as aldehyde, ketone, carboxylic acid, esters, amides, acid chlorides. And if you look at this picture and this carbon is electron deficient and is denoted by a partial positive charge, and the oxygen carries a partial negative charge, hence it means it's electron rich, and the bond is polar. So there is a dipole moment from going from carbon towards oxygen, and this shows that sigma positive you often see in reaction mechanism of organic chemistry. The sigma positive character shows the electrophilic center and the sigma negative character shows the nucleophilic character. So these are the sites which help us to predict the outcome of a reaction, and this is how we can use electronegativity to understand the reaction mechanism in organic chemistry. Alright, you have seen number of research papers published on density functional theory in which people put these images, and you see the coloring also indicates this one is a rich in electron density and this is poor in electron density. Our top one is going increasing electron density and the bottom is decreasing electron density. Let's apply this concept to a real molecule, that is CH3Cl. Now Cl is more electronegative, hence it carries a partial negative charge, and carbon is positive in character, are less in electronegativity, hence it carries partial positive charge. And if you look at the map shows the electrostatic potential plot, and the top side is rich in electron density and the bottom side is poor in electron density. And this will be helpful, this concept of electronegativity will be helpful, again I am repeating, to predict the acidity and basicity of organic compounds. It will be helpful to predict the outcome of a reaction by identifying correctly the electrophilic and nucleophilic center in any molecule. And C, it will give you the information about the polarity of the bond in which will translate into, you can figure out solubility of compound by knowing the polarity of the compound. So this is very fundamental chemistry lecture about electronegativity. I have covered most important points about electronegativity. I hope you like this video. Please subscribe it and share it, the link with friends for more amazing videos. Thank you for watching. See you. Bye.